Alright, let's move on with these examples. Find the vectors and Cartesian equation of the plane that passes through 3 points. And another example here where a plane in space can also categorized by 3 non-collinear points, right? These 3 points are not parallel, means that AB is not parallel to BC and not parallel to AC. So these 3 points cannot draw a straight line, okay? You cannot using these 3 points to draw a straight line. So means that any 3 non-collinear points on a plane, you can actually define the equation of plane. So let's back to the concept here. So we have a plane, right? We have a plane. Then the plane consists of point A, which is -1, 2, 0. Point B, which is 3, 1, 1. This is just for illustration, okay? It's not accurate. So it's just to tell you the concept, how to finding the equation of plane, right? So the problem in these cases here is, as we know that to find the equation of plane, we need 2 information, right? We need a point, right? There are no problem for this plane. We consist of 3 points, right? Any point is okay, right? We have 3 points, so A got no problem. But the value of normal, the normal vector is not given, okay? There is no normal vector here. But with these 3 points, we can actually define the normal vector of the plane, alright, by applying the concept of cross product, right? As you learned before in previous lesson, for cross product, let's say you have 2 vector which is non-parallel, right? 2 vector which is non-parallel. So when you're doing cross product, alright, when you're doing cross product, you were getting a vector, let's say you're getting A cross B, right? So you were getting a vector A cross B, right? So or you use your right hand rule, right thumb rule, right? So if you're going clockwise, right, you're going clockwise, so means that anti-clockwise, all right, from A to B is anti-clockwise, right? Anti-clockwise, lawan jam, right? So then your thumb will moving upwards, right? So you see my hand, it's just like slapping people. See my thumb going up, right? A cross B. So means that this A cross B is always perpendicular to B and also perpendicular to A. So same thing also when we're doing B cross A, all right? B cross A. We were getting a normal vector as well. This 2 vector is just anti-direction, right? But they actually is also a normal vector which is perpendicular to A and also perpendicular to B. So, and this will be B cross A, right? Clockwise direction. So if you see that, clockwise direction, this is counterclockwise, so going up the thumb. So anti-clockwise, right? Anti-clockwise. So if you see anti-clockwise, clockwise, so the thumb will be going downwards. So means that A cross B and B cross A is the normal vector for A and B. Alright, it's perpendicular to A and also perpendicular to B. So now I'm going to using this concept in apply into the this plane in finding the normal, right? So what's the concept here? As long as you have 2 vector on the same plane, right? 2 vector on the same plane. Once you cross the 2 vector, you are getting the normal of the plane, right? This is a very important. I repeat again. So if you have 2, let's say you have 3 points. This 3 point is on the plane. It must be on the plane. So, and this 3 point is, you can drawing a direction vector, right, from A to B and the vector from A to C, or any vector, or B to A or B to C, or C to A or C to B, any vector, as long as you take that 2 vector, you cross, you are getting a normal vector. But for easy for me to explain to you, I will choosing AB cross with AC or AC cross with AB. Alright, okay, let's see what's the meaning here. So, right, okay, let's go through. So if you want to find a normal vector, let's say I want to find a normal vector that going up here, right? Let's say, okay, let's say this is just an assumption. I want to find a normal vector here, all right, a normal vector, a perpendicular vector here. So I need to joining A to C and A to B, right? By finding AC, this vector cross with vector AB, I will getting a normal vector which is perpendicular to this line, right? To this line and this line. Eventually, it's perpendicular to the plane, right? So this will become the normal of the plane. So the very simple explanation will be, if you want to find the normal of the plane, I have to get two vector. So very easy, I getting AC, A to C, the vector A to C cross with the vector A to B, cross with the vector A to B. All right. Some students were asking me, sir, can I find the normal vector that from B, right? Yes, you can, right? You can, but you have to apply BA cross BC, right? BA cross BC. Can I find a normal vector for C by applying ABC? Yes, you can. You take CA cross CB or CB cross CA. Any vector, as long as you get the normal vector, this is fine. So easy for me to explain, I was telling you, I was taking AC cross with AB. Alright, so now the first thing I must do is I must get the normal vector here. So before I getting my normal vector, I have to find AC, the vector AC, and vector A to B, right? So how to find the vector A to C? So A to C is defined to be OC minus with OA. Alright, OC minus with OA. And AB will be OB minus with OA. Right? So I can convert each of the point here into a position vector where the OA, right, which is the position vector for A, is actually negative 1, 2, 0. Alright? And OB to be O to B, 3, 1, 1, right? A position vector. So, and O to C from origin is 1, 0, 3. Alright? So I have negative 1, 2, 0, 3, 1, 1, and 1, 0, 3. Right? So later on, I'm going to using all this position vector in finding the vector AC and AB. So now let's find the vector AC and AB. So OC minus with OA. So OC is 1, 0, 3, negative minus with OA, negative 1, 2, 0, which give me 2, right? Which give me 2, 1 plus 1, negative and positive, 2, 0 minus 2, negative 2, 3 minus 0, you have 3. So it means that the vector AC from A to C, the direction will be 2, negative 2, 3, right? So now finding for the vector A to B. So A to B will be OB, 3, 1, 1, minus with OA, right? OA, negative 1, 2, 0. So you are getting 3 plus 1, negative, negative. So you have 4, 1 minus 2, you have negative 1, and 1 minus 0, you have 1. Now you have done with getting the vector AC and AB, right? So now it's time for you to find the normal. You know that you want to find the normal as long as you take the vector AC cross product with AB, you are getting the normal of the plane, right? All right, let's do cross product. Why we are doing cross product? So we want to find the normal of the plane, right? So we are taking AC crossing with AB. And some student, some student were asking, sir, can I taking AB cross with AC? Yes, of course you can. Because why? If you're taking AC crossing AB, maybe the normal vector is going down, right? But it's still a normal vector, right? Doesn't matter, as long we get a normal vector, we can do it. So, but for my example, I just do once for you, which is AC cross AB. So AC. So what is your AC? So let's write with I, J, K, and AC will be the first vector. So AC will be 2, -2, 3. Right, 2, -2, 3. And AB will be 4, -1, 1. Right, so now we are focused on doing the cross product here. So how to doing cross product? So you have learned. So we are actually writing minor I, positive, negative, positive, right? Just like doing finding determinant of a matrix. So what is the minor for I? Close the row, delete the row and column. You have -2, 3, -1, 1, right? And for this J, delete the row, delete the column. You have 2, 3, 4, 1. And for K, delete the row, delete the column. You have 2, -2, 4, -1, right? Define and make sure this is correct. Then only you proceed. All right, let's evaluate the normal. So the normal vector will be -2, right? -2 minus with -1 times 3, -3, I, right? Negative with 2 times 1, 2, minus with 4 times 3, 12J, followed by positive 2 times -1, -2, negative with -2 times 4, -8, so -8, so getting K. So finally we have getting the normal vector to this plane, -2 plus 3. So we have I, right? We have I. And this we have 2 minus 12. We have -10. Negative, positive 10J. Right? And -2 plus with 8. -2 plus with 8. We have positive 6K. So this will be the normal vector of this plane, right? So finally, we have get the normal vector. This is so difficult to get the normal vector because why? The question does not given you any normal vector, right? So you have to apply the knowledge that you have by using cross product. You actually can find the normal vector. So now you have normal vector, you have a point on the plane. So let's see how to find the equation of the plane. All right. Now we have normal of the plane, right? After we calculated, the normal of the plane is I plus with 10J plus with 6K, right? I plus 10J plus with 6K. So then later on, we have the normal, we have point on the plane. So the student was asking me, sir, which point to choose, A, B, or C? Is it must choosing A as the point? The answer is no. You can choosing any point on the plane. Listen again. You can choosing any point on the plane to substitute into your A here. So you can try. So R dot N. So your N here will be I plus 10J plus with 6K equals to A. So is it A must choosing A? No, right? It's A is a point, right? It's just telling that it's a point on the plane. So okay, of course I choosing A now. So later I show you, is it choosing B is also getting the same result. So your A will be -1, 2, 0 dot with 1, 10, 6, right? Your N. A dot N, right? Your N. So I'm writing in this form so that I can calculate -1 plus with 2 times 10, 20 plus with 6 times 0, 0. You are getting 19, right? 19. Some student will say, sir, can I using B? Right? So you can always try. So K, now I'm using B. Even though here is A, doesn't matter as long as the point is on the plane. Right? B, 3, 1, 1. So dot with 1, 10, 6. It's a magic, you know. right? Different number, different xyz, different xyz. When you multiply with this normal, you're getting 19, right? Let's see, you try. Okay, 3 times 1, 3, plus with 1 times 10, 10, plus with 1 times 6, 6. So you're still getting 19, right? Can you see that? So if you just try one of the point, is already enough. Okay. Never mind. If I can try for you again, all right? Let's say I plus with 10j plus with 6k. Now I'm using point C. Just now I'm using B. Now I'm using C. So 103. We're just trying, right? When we study maths, we have curiosity. So 1, 6. So 1 times 1, 1. 0 times 10, 0. Plus with 3 times 6, 18. You are still getting 19. Right? How come x, y, z, different value, multiply with the same vector, you're getting a same value? This is a knowledge that we miss out, that we're not learning yet. We're going to learn this in university. Alright, it's a linear combination. Alright, it's a linear combination in linear algebra. But for your knowledge for now, I just want you to know that you can using any of the point here. So now for this case here, so I'm going to show you. So sorry, let's see. So now we have a vector equation of the plane, which is I plus with 10j plus with 6k is equals to 19, right? So this is r dot n. R dot n equals to a dot n. All right. So this is a normal of the plane. All right. So this is a vector equation. Okay. Vector equation. So how about the Cartesian equation? Okay, easily you can just, okay, just now I have shown you in the previous video, we have actually doing dot product between x, y, z and this, right? So or shortcut, we can see I, we changing become x, and 10y, and plus with k becomes 6z equals to 19. And the coefficient 1, 10, 6 is actually normal of the plane. Alright, so that's all for this video, and I'm teaching you. The most important thing is, let's say if you're given 3 points, can we find the normal vector of the plane? Yes, you can. You can apply AC cross AB, or AB cross AC, or BA cross BC, any two vectors that are not collinear, right? As long as this 3 point is not collinear, you can find a normal vector of the plane. Alright, that's all for this video. See you in for the more example in the next video.